section for this is called graph interpretation. Okay, so whenever they're referring to graph interpretation, they're referring to this. So they'll give you sketches and then they'll ask you to work out certain things, right? So the first thing that we're going to do is look at the lengths OS and MH. Okay, let me highlight them for you. So the distance from O to S, look where S is. It's on the straight line. It's on the x-intercept. It's a straight line. Which of the two lines is it? Is it going to be this first one here? Or is it going to be the second one? Which one do you guys think it's going to be on? First or second?
I think the first one.
Yeah, it's going to be the first one. Why? Because the gradient here, okay, M is positive. So if M is positive, that means your graph is upward sloping. So that's why we're going to use that one to work out what OS is. So an x-intercept, right? We always make what 0?
Y.
Perfect. So x-intercept, make your y 0. And like I said, we're going to use the first one. So 0 equals 2x minus 1. You get a mark just for substituting that in. Now, the next step, we want to solve for x, and that will give us the x coordinate. So -1, balancing method. If it's -1, goes over to the other side, becomes +1 is equal to 2x. Divide both sides by 2. Therefore, the x value is 1/2. Okay. Now, they're looking for a length. Now, remember, lengths are always positive. So the length from O to S is equal to 1/2 a unit. Okay. That's how we work that one out. Now, they're looking for MH. Now, we're first going to work out the distance from M to 0. Then we're going to work out the distance from O to H. Okay, let's work out the distance from O to M. To work out the distance from O to M, which graph am I going to use and how am I going to figure out what the coordinates of M are? So this time we're dealing with a y-intercept. If you're dealing with a y-intercept, we always make the x equal 0. Okay, so we're going to use first graph or second graph this time. So this time we're going to use the second graph. Why? Because we have a downward sloping graph. So that means we have to look at the one with the negative gradient. So let's go ahead. This time we said we're making x equal to 0. So y equals negative. Where you see x, you plug in your 0 plus 5. 0 multiplied by a negative number, that's just 0 there. So y here is equal to 5. So the distance from O to M is actually 5 units. Okay. Now we're not done because we only just worked out that distance there. We now need to work out the distance from O to H. What do you guys think we're going to do there? So let's follow the same pattern, right? We have the y-intercept. We're still working with the y-intercept, but this time we need to find the coordinates of H. How would I do that? Someone talk me through it. Any volunteers?
Make x 0.
Right, so we're gonna make x 0, right? And which graph or which equation should I make it in? So the first one or the second one? So look at the graph, it's upward sloping, right? So if it's upward sloping, we can't choose the one. Perfect, the first one. So y equals 2 multiplied by 0 minus 1. 2 times 0, that's just 0. What we are left with is 0 minus 1 minus 1. So the distance from O to H. Now remember, distance is always going to be positive, right? So the distance from O to H is actually 1 unit. So What's the total distance from M to H? What do I then do at that point? I'm going to add 5 and 1, and that will give me 6 units. Right, that's how I work that one out. Any questions regarding that first one? No? Okay, so I'm going to go on to the second question, 1.2. Now, 1.2, let's look at what we're looking at. J, that's the intersection point between the two graphs. What do I do to work out what J is? If you want to find the
You could use both equations.
right, what am I going to do with both equations?
You could say 2x minus 1 equals minus x plus 5, and then you carry it over.
Perfect. Okay. So first things first, whenever we need to find the intersection point of two graphs, okay? So I'll make a note here. Intersection point, PT means point. You just make your two graphs, make two graphs equal to each other, okay? So that's what we're going to do here. 2x minus 1 equals minus x plus 5. Right. We want to group all our x's on one side. So 2x plus x is equal to, that's 5 minus 1 becomes positive 1. So here we have 3x. On the other side, we have 6. Divide both sides by 3. Therefore, the x coordinate is equal to 2. How do I find the corresponding y value? What can I do there? I'm going to sub the point x equals 2. Does it matter which graph I sub it into?
No.
No, it doesn't, right? So you can sub x equals 2 into either of the two graphs. Okay, so I'm going to choose the simpler one. I'm going to choose the y equals negative x plus 5. So where I see x, I'm plugging in 2 like that. So look, our y coordinate is now equal to 3. So the coordinates, right, of J are 2 and 3. There we go. All right, that's 1.2. Now, let's go and look at the third question. So now with the third question, they want us to calculate the length of EF. If OL, okay, the distance from O to L is 2 units, then they want us to work out what EF is. So we're going to use our knowledge from what we did in the first question and apply to this one, right? So let's erase the unnecessary stuff here, okay? What are they telling us? They're telling us that the distance from O to L, that distance there is 2 units. If the distance from O to L is 2 units, what's this coordinate actually equal to? The x one, what's the x coordinate equal to? Look at the position on the x-axis, right? Yes, say that again, love. -2, right? Do we agree that
Yeah,
it's
-2 and 0.
perfect? Okay, so the point here is x is equal to -2 and the y value is 0. Perfect. Now, we're going to use this. X is equal to -2. When we do that, right, I'm going to find, so I know already what the E coordinate is. It's -2 and something. I need to work out the corresponding Y value. Then for this one, I want to do the same thing, okay? I want to work out the corresponding Y value for that one. So both these coordinates, okay, E and F will both have -2, Okay, x being equal to -2. I just need to work out what the corresponding y values are. Once I've done that, I'll be able to see what the distance from E to L is, and I'll know what the distance from L to F is. Add the two, and that will give me the distance EF. Okay, let's go ahead and do that. All right, so first things first, you guys tell me what I should do. So I know that x is equal to -2, right? So what am I going to do with that -2 value? Where should I plug it in?
You can substitute in the second equation.
Perfect. So sub x equals -2 into the equation y equals -x plus 5. I'm using the -x plus 5 because that's the downward sloping one. That's what I'm going to do there. So y equals, right? Negative in brackets. You have to put the -2 there. Okay. Then plus 5. Negative and negative, that is positive. So 2 plus 5. So the corresponding y value is 7. Perfect. There we go. That's the first one. So we know the distance from E to L, that is 7 units. From here, I now need to sub x equals -2 into the other graph. Now the other graph is upward sloping, y equals 2x minus 1. Let's go ahead and do that. So 2 times -2 minus 1. This is -4 minus 1. Here we go, y is -5. Okay, now what did we say about distances? Distances can never be negative, okay? So the distance from L to F is actually 5 units, right? What then is the distance from E to F? What should I do? So the distance from E to L, remember, was 7 units. Now the distance from L to F is 5 units. So what's the total distance from E to F?
12.
Perfect. 7 plus 5 equals 12 units. Brilliant. Well done. Now, they're going to ask us to do it the other way, right? Now, this one is a slightly more complicated question, right? Why? Because they've told us that the distance from A to Y is 12 units, okay? They've told us that much. What we now need to work out is what the corresponding x value is, right? So this time we have 12 units from A to Y, okay? What is the distance from O to P? To find the distance from O to P, we need to find what the x coordinate of P is equal to. Right. Okay, I'm going to talk through this one very slowly, right? Now, remember when they give you an equation, okay, like y equals 2x minus 1, that's actually what the actual value of y would be given some value x. So the point at A, okay, is actually y equals 2x minus 1 because we don't know what the x value is. Then the point at this y here is y equals -x plus 5. Now, the distance between these two. I'm going to take the first one. Okay, so distance 1 or position 1 and subtract it from position 2. Now, why I'm saying subtract here? Because you'll get a negative and a negative, which gives you positive. So 2x minus 1 minus, you have to put the second graph in brackets like that. And this is going to be equal to 12 units. Okay. So 2x minus 1, we distribute that negative sign into the brackets. Okay. Positive x negative 5 equals 12. Group like terms, 3x minus 6 is equal to 12. 12 plus 6. So 3x here is equal to 18. Therefore, my x value, so if I divide both sides by 3, my x value is equal to 6. That would then mean the distance from O to P, 6 units. Okay. So I know this one is much more complicated than the other ones, right? Yeah, so as we do more and more, it'll become more clear to you and it will make more sense. Okay. So whenever you're given two distances like that, okay, you have to use the actual equations as if they were points. Okay. And you subtract the two. The reason why I say subtract here, okay, is because this other value here at the bottom, the y1, it's going to become a negative and negative, and then that's how you get that. So same way, if we were to do the same thing here with the points, let's look at this previous one, the E and F, right? Remember, you had the distance here. This one was 7 and this was -5. So if I apply this rule, the 1 minus 2, it would be 7 minus 5. You see what happens there? This becomes 7 plus 5, and that gives us the 12 units. Okay. So yeah. Right. So don't worry too much about this last question. As you do more and more, it'll become clearer. Okay. So let's go on to another question. Since we've done two, what do you call this, straight lines, let's look at a, oopsie, I don't know why I did that. Sorry. Okay, here we go. Let's look at this one. Okay, so this time we're dealing with a parabola. Okay. The equation of the parabola is y equals 1/8 x squared minus 2. Okay, first things first, determine the distance from O to M and O to N. Okay, so O to M and then O to N. How do we work out the coordinates of M and N? How do we work out the
y0.
Perfect, good. So we have x-intercept, we're going to make y equals 0, right? And 0 equals 1/8 x squared minus 2. You want to isolate your x squared. So let's do the balancing method, right? Inverse operations, that's 2, positive 2, right? It was negative, and now it's positive. 1/8 x squared. Then if you have 1/8, you want to get rid of 1/8. That means you have to multiply both sides by 8 like that. So 16 equals x squared. We're almost there. Last step, square root of both sides. But what happens when you take the square root of a number? You get a positive value and a negative value. So the coordinate at N is actually 4 and 0. The coordinate at M is -4 and 0. What are the two distances from O to M, then O to N? So O to M, distance is 4 units, and as well as the distance from O to N. Okay. Distance is always positive, right? Then next one, GF. Now this distance from G to F, okay, if the distance from O to G is 2 units. Right. Let's first think of the coordinates of G. Coordinates of G, what do you guys think they're going to be?
-2 and 0.
Perfect, okay? -2 and 0. So we now know that the point here, okay, G, that's -2. The X value is -2, the Y value is 0. So if I know that I have X is equal to -2, how would I work out the coordinate of F? So for F so far, what do we know as well? What's the X coordinate for F? It's also -2. Perfect. What we need to work out is the missing Y value. So how do I find the missing Y value? What do you guys think I'm going to do?
Sub -2.
Into Y equals
The
1 over,
equation.
yeah. So 1/8 X squared minus 2. So let's go ahead and do that. So 1/8 -2 squared minus 2. So -2 squared, that becomes 4/8 there minus 2. What's 4/8? 4/8 is actually a half, right? A half minus 2. What do you get? What's a half minus 2? Okay, I get -5/2, or you could write it as -2, 5. Okay, so the distance now from G to F. Okay, remember distance, it's 2, 5 units. We get rid of the negative sign. Okay, right. The equation of EJ, E to J. Okay, so this here, this straight line, let me highlight it for you. That straight line has an equation. Okay. Now, what do you guys think it's going to start with? If it's a straight line and it's parallel to the x-axis, it starts off as what?
Y.
Yeah, it's going to be y equals something. So we need to work out what that something is, right? So the equation of EJ, if P to C is 6 units, right? Now this entire distance here from P to C is 6 units. What we actually need to work out is this coordinate C. We don't have to do much to work out what the coordinate C is, right? Why? Because we already know that the X coordinate is what? Or the X value is 0. Okay, because it's on the Y axis. What's the corresponding Y value? Just by looking at this, what's the corresponding Y value? Remember this value, that's your intercept. Okay, so just by looking at it, you can also plug in 0 there. So that C coordinate is 0 and -2. So the distance from O to C is actually 2 units. What do you think the distance from O to P is actually now? So from O to P, what's the distance there?
Two units.
Say that again.
2 units.
Okay. Ashmi, what do you think? Okay, so let me show you again. Remember they said the distance from P to C, the
4.
entire,
I think it's 4.
yeah, it's 4, right? Because from O to C, that's 2. So if this bottom distance here is 2 units and the entire thing was 6, 6 minus 2, that would give us the top part, which is 4 units. Now, if the top part is 4 units, that means we know what this P coordinate is. It's 0 and what? 4. And therefore, the equation of EJ is just y equals 4. There we go. Right. Okay. So that one was also like a roundabout way of getting there. Then our last question, domain and range. We did this question before the test, right? So for parabolas, right? What's the domain of a parabola? Who remembers? Does anyone remember? Okay, so domain of all parabolas, x is an element of real numbers. Okay, then the range looks at the minimum value, okay, and it's always going to be y is greater than something or y is less than something. Okay, so for this one, what's the lowest y value that we can see from our graph? Or where do we see the lowest y value on this graph here?
Zero and -2.
Yeah, so here the lowest point is -2. That means the rest of the graph is strictly what? Above -2. So our range is greater than or equal to -2. There we go. That's our domain and range of a parabola. Let me give you another example. So if you have a parabola that looks like this, okay? And I ask you and I tell you that this is 2, right? What would the range and domain for this one that I just drew be? So domain, what's the domain? This one is simple now. X is an element of real numbers. And the range, you guys tell me, what's my range for this one? It's a frowny face, sad face. Okay. What's the maximum value? The maximum value is 2. That means the range is strictly less than. Yeah, so it's going to be less than or equal to 2, like that. Right, let me draw another one because I think now this one is a little different. Okay. This value here is -3. So another way of asking this, what's the maximum value of this graph that I just drew? The maximum value would be -3, okay? Because there's no y value above that. What would the range be? And what would the domain be? The range, same thing. What do you guys think? You guys tell me. Now, this one's going to be different. What do you guys think? It kind of looks like this one, the one that we just did, but there's only one thing that's going to be different. So here, range y is also strictly less than or equal to -3, like that. What do you think the range of this next one is? Okay, that is 7. What's the range? Do you think this one's going to have a maximum value or a minimum value?
A minimum.
Yeah, it's going to have a minimum. Okay, so the minimum value is equal to 7. Okay, it's not going to have a maximum because these arrows here tell us it continues all the way up to infinity. So it's not going to have a maximum, but it will have a minimum. Now, the range for this one. Range is, if it has a minimum, strictly greater than or equal to 7, like that.